Well, hello again, and welcome to the VK6CS Fun with Amateur Radio channel. Now, you might remember yesterday, I think it was, or the day before, I just did this doodle on the board here and said this is what I had in mind. This is looking down on the airbox, fan on that side, offset, so hopefully the air would rotate and come up through the tube. Now, I apologise if the focus went a bit wobbly there, but I can't be close to the board and see the viewfinder at the same time. Now, believe it or not, and you'll find this hard to believe, I know, but shocking but true, I managed to psych myself up and cut those large holes in each side of the airbox, and I've temporarily fitted the fans. So, there it is. Okay, so I've got a fan on that side and a fan on that side. As you can see, they're offset. This one is towards the back, this one is towards the front. So these are the big holes I really didn't want to cut, but didn't have much choice. The bottom is sealed, it's just sitting on top of a 12 volt power supply, and the valve base is just plopped in there. This is sealed, so it's quieter. I'll give you a demonstration. Now that sounds still quite noisy, but it is quieter. It is quieter than it was. So just out of curiosity, let's see how it does with airflow. And time for 1 minute. Let's see what the airflow is like. As you can see, can you see? Actually, yeah, you probably can. There's some fairly decent movement on the airflow meter. So should be a reasonable amount of air. Remember, with the fans in series, I got just under 84 cubic feet a minute through the tube. 30 seconds. It's not going to be far off. It's not going to be far off. Now, although it's still reasonably noisy, I think that's a good bit quieter than it was. And once that's inside, if this has got a suitable amount of airflow, once that's inside the amplifier case, it's going to be quieter still. Here we go. It's coming up to now. So what's that? That's 800. That's 881. So 881. Let's have a look. Let's nudge the tripod as usual. So that's 881 multiplied by 0.09 gives me 79.29 cubic feet per minute of air through the anode radiator. 79.29 cubic feet. So I've lost about 4 cubic feet a minute. Now it was 4 cubic feet a minute shy, because I had about just under 84 cubic feet a minute, and I thought that might be okay. So you've got to bear in mind, you know, it's amateur SSB. Although I've seen on the net that it's supposed to be you're supposed to have a minimum of 88 cubic feet a minute through this tube. I think for SSB, you know, 79.29. I mean, that's close enough to 80 cubic feet a minute, really, isn't it? 80, and I've left the radio on again. Yeah, that's 80 cubic feet a minute through that anode radiator. To be perfectly honest, I think that's going to be that'll be adequate, because it's only going to be run in SSB, and the chances of me using it in full carrier modes not very likely. I've hung up my skull and crossbones, so it's very unlikely that I'd be broadcasting on the AM band medium wave with it. I wouldn't rule it out, of course, but So I reckon 80 cubic feet a minute, or 79.29 cubic feet a minute of airflow through that anode radiator, I think is going to be fine. I'm tempted to try that because the PA is going to be modular. Once it's actually running and it's loaded, and of course I wouldn't do it into an antenna, heaven forbid, but into a dummy load. If it runs somewhere between a kilowatt and 1.5 kilowatts into a dummy load, depending on the efficiency of it, of course, then it may not be dissipating anywhere near what it's rated for. So probably half the airflow or less would do. But under those conditions, I'll just load it up. Maximum smoke, I believe, is the term, and I shall use my little contact-free thermometer just to look at the anode temperature when it's all loaded up. Obviously not now, but you get the picture. So when it's loaded up and it's running into a dummy load, I'll check that anode radiator temperature, and as long as it's nowhere near 200 degrees centigrade, I think that'll be fine. I might try just a couple of other experiments just to see if by changing the airflow slightly within that box, maybe within here, I could maybe put a couple of baffles in there just to sort of steer the air. I might try that before I say okay, I'm going to sort of bolt it in the amp and give it a go, just to see if I can squeak it up a bit. But if I can't, then I can't. I think that amount of airflow is going to be fine. I've got to condition the tube, so I'll maybe run it up with the heater on and some airflow running through it, and just look at the anode temperature. Because I know with the smaller metal ceramic valves you have to have the blower on to keep them cool when the filament's on. I think that's going to be the case with this one, but it'll be interesting to see how hot it gets without the HT on it. So just the filament and the blower. Just have a look at the temperature of it. But yeah, I think 80 cubic feet a minute. I mean, that's pretty close. And I'm not really going to be. I'm not really interested in smoking it in competitions. I know some people run these with 4,000 volts on them, and they say you need a lot of air. And I thought, yeah, I'm not surprised with 4,000 volts on them. I mean, the specification says 3 kV maximum, I think. I want to run it in spec. So 2,800 volts on the anode. That's not under load, so that's going to drop a little bit. So it'll be interesting to see how much power I can get out of it into a dummy load. If it does a kilowatt, I'll be happy. If it does more than a kilowatt, I'll be delighted. But once it's actually running, I'll get a much better idea of how happy it's going to be. But I will just do a couple of other things, just with the some internal baffles inside the box, just to see if I can squeak that up just a tad. And before someone starts talking on the Rolling Stone repeater, I think I'll wind this one up. So, as always, hope you found that interesting. And thanks for watching. I'll catch you next time.